Well, I made it back. The values are in. And now we're going to make the normal probability plot. So what happens here is we put the data values on. It looks like this. Data is this axis. The expected z is on that axis. So the data was in list 1. The expected, I'm looking at this. And the expected z is in list 4. So here we go. We're going to make a stat plot. Go into list 1. Type is scatter plot. Which I guess is that one. Okay. Okay, and then the X list we're using is list 1. The Y list we said was list 4. Go. Hit enter, make sure it's active. Then I go over to graph. And then I go zoom. Maybe zoom stat works this time. There we go. So we see it's curved like this. So that's how much curvedness you see when something's skewed as much as what we had. Where'd it go? Here it is. It's just a little bit skewed, so it's not terrible. So you see that not too far off of the line. Normal probability plot. Ordinarily, if you're doing a procedure that requires approximately normal data, that's not too bad. When things are bad, you really see more of a curve. So it'd be a judgment call whether you're going to take it or not. And we went through the effort of constructing it, but the calculator knows how to do it. So let's go ahead and take a look at how the calculator makes exactly that same graph. Here we go. So I'm getting out of here. I'll clear all that stuff up. So I'll go back to stat plot again. Turn it on. Go down. So way over here is the normal probability plot that's in your calculator. Hit enter. And then it'll ask you where the data is. We said it's in list 1. And then where do you want the data? So we have got the data axis and the z-score axis to worry about. And we're comparing it to probability plots that have the data axis, the x-axis. Keep that. Hit enter. And then we'll go back to graph. And there it is. So that window that we used, of course, since it's exactly the same values, you'd have no way of knowing that the calculator had just computed those, but it did, using the procedure we used. So there you go. You have found out how to use your calculator to make a normal probability plot, but we're not quite done. Okay. So there's a way to use the correlation coefficient to determine how straight that is. I'm curious what it's going to do for this data. I'm sure it's going to reject the idea that it's normal, but it's really not that badly not normal, but we'll see what it does. So here's the sample size. Our sample size is 12. And so here's the critical value in this procedure, 0.928. So it says we need R at least 0.928 for the data to be normal. So you can be pretty sure the data came from a normal distribution if that R comes out from the normal probability plot. In other words, the normal probability plot is determined pretty much a straight line because the R is 0.928 or more. So now I have to find a way to get the correlation coefficient here. So we said we used list 1 and list 4. So we know how to do it. We go to stat, calc, and then we go to linear regression. And now we do something. We don't care anything about the regression procedure, but we do care about the R value, which is the only way you get the R value, I guess, on the calculator. So we need to put list 1 and list 4 in there, since that's the graph of list 1 versus list 4. We go down to calculate. We get R 9685. 9685. R is 0.9685. So as far as the calculator is concerned, all is well. It's not curved enough that that might not happen by accident. So this data is not crazy enough that it couldn't have come from a normal distribution. It can happen. So if you did normal distribution size 12 and did histograms for a while, eventually you'd see one that looks a lot like this. Just that kind of thing that can happen randomly. That's so exciting that we got this all done. I'm more excited than you because I had to try a few times on some of these videos, but now it's done. Yay. And we'll see you next time. Happy probability plots to everyone. And I'm stopping recording.